So, I gave you a little trick to factor when it gets ugly like this. But then I asked you to do number 10, and number 10 is a little weird. Because it almost looks like it works, except you notice that those two factors aren't exactly the same, are they? The yellow one has a positive 2x and a negative 3, whereas the green one has a negative 2x and a positive 3. But even if you forgot, there is a way you can change the way things look, but not change their value. And that is dividing or multiplying by what? I know you know. Well, there's 30 other people that need to know. What is the thing that you can divide or multiply things by and have them not change in value? Fortunately, I have 80 minutes to wait for this answer. Yes, Michael. 1. Well done. If you multiply or divide by 1, the value doesn't change, does it? Excellent. So, since we are factoring, would we be multiplying or dividing by 1? Dividing. Excellent, Emily. Well done, because factoring is dividing. Great. So I have to divide by something that's not going to change the value, which is 1. But I have to change this positive 3 to a negative 3 and this negative 2x to a positive 2x. So I can't divide by 1. What must I divide by? Negative 1. So if I divide this guy by negative 1, that means that's my greatest common factor, right? And greatest common factor goes to the front, doesn't it? So that negative 1 would come out here. But what's already out here? A negative 5. What do we do with coefficients? Just like we did in radicals when we were simplifying radicals. Multiply. What's negative 1 times negative 5? Positive 5. So now, all of a sudden, I have x, 2x minus 3, plus 5, and this, since I took out a negative, is now negative 3 plus 2x. Now, are they the same? Yes. Once they are the same, we can use our trick to substitute a different letter for it. Correct? So what I have there is x times a, if I'm going to use a, plus 5 times a. What's my common factor now? A, which means I can divide a out of there and I get a times x plus 5. But what's a? 2x minus 3 and x plus 5. Does everybody understand that move? It's incredibly helpful in factoring. Do you need to use it? No, because you can always expand everything and factor it. But that takes a lot of time. And since the number one excuse all of you have for not doing your homework is you don't have enough time, I would suggest that you learn that move to save some of that time. Some of you need help telling time, which is different than needing to save time. He's not looking. It's not worth it. Important message. I also asked you to expand these two. That means it's x plus 3 x plus 3, x plus 3. There's all kinds of ways to do that. The way I suggested that you do that is forget the first one. Expand the second one, since you can use the shortcut, x squared plus 6x plus 9, and then distribute that through. X cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27, x cubed plus 9x squared plus 27x plus 27. And this one, it's just FOIL, 10x squared minus 6xy plus 20xy minus 12y squared, 10x squared plus 14xy minus 12y squared. And that is where I left you. Just to make sure everybody knows what they're doing, I'm going to put 4 questions on the board behind me right now. They are of this type, 9 and 10, with where factors are binomials. See if you can do these. They're in different colors. Ah! Ah! There. When they are done, we will move on to the third kind of factoring that you have learned. You have learned GCF, you have learned trinomial factoring. We will move on to the third kind of factoring, which you already know how to do from trinomial factoring. Number 3 and number 4, the blue and the green one, are quite tricky. Most of you will probably get part of the way through. Talk to me about what some things you tried with these, because these are really hard. Don't get me wrong. Right? These are really hard to do. Okay, that's why I gave them to you now, let you work together, and why we just went over it. What is something you could have tried with the first one, the black one? What is something you noticed in the black one? Evan. You notice this, correct? Are they the same? So could I make it simpler by going A and A, which would give me A squared plus 9A minus 10, wouldn't it? Everyone agree? Is everyone okay with that? Now, does that look like something we know how to factor? Sure it does. We've done that a ton, haven't we? That, I need two numbers that multiply to negative 10 and add to 9. What are they? Is it 1 and 10? 1 and 10 won't make 9? How? 1 and 10. How will I make those two numbers add together in some way to make 9? 10 minus 1, correct? So it would be A minus 1 and A plus 10, wouldn't it? Except there is no A in the original question. What is A? X plus y minus 1. And what's A? X plus y plus 10. And now it's done. Because x, y, and 1 don't share a factor. Everybody cool? Okay. What do you see in this one? Same thing, right? So what should I do with those? What could I make them? Another letter, right? I shouldn't use x or y because I've already got x's and y's. So I'm going to go ahead and I'm going to use a again. So what does that give me? A squared minus 2a minus 63, correct? And that looks like something we can factor. I need numbers that multiply to what? Negative 63 and add to what? Negative 2. Is it 1 and 63? Is it 3 and 21? Is it 7 and 9? Yes. How will 7 and 9 go together to make negative 2? 7 minus 9, correct? So I have A plus 7, and I have A minus 9. But there's no A, is there? What's A? 3y minus 4 plus 7. And 3y minus 4 minus 9. Now, do you see some more math you can do there? Where, Emily? I don't want to multiply because I'm trying to factor. I'm trying to break it down. So, what do you see right there? Negative 4 plus 7, which is what? 3. Right? Because we collect our like terms every chance we get. Yeah? Now, did some people get to here? I would like to think so. So this is now 3y. Negative 4 plus 7 is plus 3, correct? And what is negative 4 minus 9? No. Negative 13. Now, what do you see there? That was a bad way to highlight that. What do you see there and there? 3 and 3. Is that a common factor? So could we divide a 3 out of there? Where does that divided 3 go? To the front. Three. What's 3y divided by 3? Y plus 3 divided by 3 is 1. Is there any common factor with 3 and 13? Nope. So it stays the same. Now, that's your final answer. Now, a lot of you will say, Mr. Myers, how could you possibly ever expect us to get to that? You never showed us that. But I did. Because I showed you the substitution move. You know how to factor that. From grade 9, you know what to do with like terms, which took you to here, which showed you a greatest common factor, which we did to death. And that gets you down to there. Was it easy? Every piece of math we did, I think, was pretty easy. You have a map to get there. Was it complicated? Yes. What is the only way to defeat complexity? Simplify and practice. Go step by step. Now, what do you notice in the blue one? What do we see in the blue one? You see these. Are they the same? But they're a little weird, aren't they? Because aren't those, can't we factor those? There's an X there and an X there, isn't there? So we could factor that, couldn't we? But that would make it really complicated right now. So let's go with what we know. Since those are the same, I can make them another letter, which gets me a squared plus 8a plus 15. That looks like something we can factor. I need to multiply to what? 15 and add to what? 8. What is it? 3 and 5. So I have a plus 3 and I have a plus 5. There's no a in the original equation, so what do I do? Put my a back in. X squared plus 4x plus 3. Right? And what's this one going to be? X squared plus 4x plus 5, correct? Now, look at those two things we just made. Do they look anything like something we can factor? They do, don't they? This one, I would need to multiply to what? 3 and add to what? This one right here. Just that one. Just that guy. What would I have to add to? 4. I don't know why it takes that long to get an answer when right up here everybody knew it was 15 and 8. I don't know why you have trouble seeing that that is 3 and 4. What are the factors of 3 that add to 4? Is it 1 and 3? Yeah, because they're the only factors of 3. So that's x plus 3, x plus 1, correct? Now, what about over here? I would need to multiply to what? 5 and add to 4. 5 only has 2 factors, 1 and 5. They will make 4 if there's a subtraction involved, correct? Is there any subtraction here? So can that guy factor? No. So we leave him alone because it cannot be factored. Please notice again, there is nothing new. It's all stuff you already know how to do. You just have to put it together. What do you see in this one? You see 2x plus 4 in 2 spots, yes? So what should I make it? Another letter. I always use a, unless there's an a already in the question. So now I have 3a squared plus 12ay minus 36y squared. What there don't we like? I don't like that 3 at the front. How do I get rid of the times 3? Can I divide it all the way through? Yep. So I'm going to divide it all the way through. So there's a GCF. So now I got 3a squared plus 4ay minus 12y squared. Correct? Is everyone okay to there? Okay. Does this look like everything else we've factored? Does, doesn't it? So I need numbers that multiply to what? What kind of 12, Ryan? Negative 12. And add to what? 4. Is it 1 and 12? Is it 2 and 6? Yes. How will 2 and 6 get me to positive 4? Positive 6 minus 2, correct? So I have 3a minus 2 and a plus 6. But since it's y squared, what do I need here? Y and y. Everybody okay? Is there an a in the original expression? No. So what do I need to do with all these a's? Put them back to what they were, correct? So that's 2x plus 4 minus 2y, right? A, 2x plus 4 plus 6y. Everybody okay there? Okay. Now, who just said that? GCF. What do you notice? 2, 4, 2, and 2, 4, 6. They all have a greatest common factor, don't they? What is the greatest common factor here? 2. So I'm going to divide by 2, aren't I? What's the greatest common factor here? 2. So I'm going to divide by 2, aren't I? Where does that greatest common factor have to go? To the front. Where does that greatest common factor have to go? To the front. What was already at the front? So what do I do with 2, 2, and 3? Multiply them, just like we do always, right? What is 2 times 2? What is 4 times 3? 12. What is 2x divided by 2? X. What is 2y divided by 2? Y minus y. Remember, in a perfect world, we put the letters at the front, right? And what is 4 divided by 2? 2. 2 divided by 2 is x. 6 divided by 2 is 3y. 4 divided by 2 is plus 2. And now that one's done. Are they long? Yes. Are they complicated? Yes. But is the math difficult? No. You know how to do everything in there. You just got to apply it. Right? Okay. Take a stretch. Talk to your neighbor. When you get back and are settled, please open up to page 133. And 2 and 1, and we are back to our third kind of factoring, which you already know how to do. All right, you've seen it already. I want you all to expand this for me properly, the long way. Don't use the shortcut. Okay? So first would be x times x, then, okay? Do that. And all of you should have gotten this, right? If we actually wrote it out. Now, you've seen this written out before, haven't you? Right? when I write it out like a trinomial, if I say factor that, you know you need to multiply to negative 16 and add to 0, right? So we know it's plus 4 and minus 4, correct? Everyone agree? All right. Now, so we know it's positive 4 and negative 4. And we can see right there, it is indeed positive 4 and negative 4, correct? Now, there are 3 terms here. Which is the term that we would never actually write if it wasn't math class? We wouldn't write the 0, would we? We would actually write x squared minus 16, wouldn't we? Right? Now, look at the title of this type of factoring. Difference of squares, right here. Difference is what math? Subtraction. Squares must mean the two things being subtracted are perfect squares. Are they? X squared is a perfect square. 16 is a perfect square, so this is a difference of squares. What that means is, if you look closely, because these are the factors, the first factor is the square root of the first term. Does everybody see that? So I'm going to go ahead and I'm going to call that first term capital A and that second term capital B. So it would be A squared minus B squared, wouldn't it? And when we factor it, to factor a difference of squares, it's the square root of A plus the square root of B, and then you just do it again with a minus. And that minus and plus is what makes this middle term disappear. Does everybody understand? One sec, Zaro. Notice the name is difference of squares. We cannot do this if it is x squared plus 16. Why? Because that would be x squared plus 0x plus 16, and I would need to multiply to 16 and add to 0. Can I? What multiplies to 16? 1 and 16. Does that add to 0? 2 and 8. Does that add to 0? 4 and 4. Does that add to 0? No. That's why we can't do it. It has to be a difference. Zaro. Because that has a square root. 16 is actually 4 squared. Do you understand what I'm saying? The reason that squared is there is for future work. I'm going to show you what I mean in a second. Now, before we go on, you guys need to be aware of something. Down at the very bottom of your page, just by the 133, draw a line. There's something that you are actually aware of, but you sometimes forget. All of you know, what is the square root of x squared? X. Because that is really x times x, right? That's a group of 2, so out comes an x, and the answer is x. Everybody good with that? Everybody cool? Okay. What is the square root of x to the 4th? X squared. Because that is really x, 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 right? Come on. Come on. Come on. Out comes an x. Out comes an x. And the answer is x squared. Is everybody cool there? Yeah? Okay. What would the square root of x to the 6th be? X cubed. Are you noticing a pattern? When it's x squared, it's x. When it's x to the 4th, it's x squared. When it's x to the 6th, it's x3. So what would x to the 12th be? 6. Is everybody with me? Now, could I then square root that? What would that be? X cubed. Can I square root that? No. I can simplify it because it's xxx, and out will come a pair of x's, so it'll be x root x, right? What is the difference between 2, 4, 6, and 12 that allows me to get a square root, but it doesn't allow me to get a square root here? They're even. Any even exponent has a square root. How do you find it? 2, 1, 4, 2. What is it? You divide by 2. So what would the square root of x to the 24th be? X to the what? 12. Everybody with me? Okay, so that's the first little trick to remember here. Difference of squares. Trick 1. Any even exponent can be square rooted. Any one. So let's look at the very, very first question here. Is that a difference of squares? Is that an even number? So can we square root it? So that one's a square. Is it a difference? Am I subtracting? Yeah. Is 1 a perfect square? Does 1 have a square root? Sure it does. 1 times 1. Right? So this is a difference of squares, which means I can follow this pattern, can't I? Square root the first one. What's the square root of x to the 16th? X to the 8 plus, what's the square root of the second one? 1. And then what is it? Same thing. X to the 8th minus 1. Is everybody cool? Now look carefully. I put this one first on purpose. x8 plus 1. Can I do anything with a plus 1? No. But what about this one? 8 minus 1. What should I do? Can I square root the 8? Yeah, that's going to give me x4. What's the square root of 1? So it's going to be plus 1. Oh, that guy's done, right? What's this going to give me, though? I've already got the plus 1. Minus 1. Look closely. Can't do anything with that. It's a plus. Can't do anything with that. It's a plus. What about here? X squared plus 1, and then x squared minus 1. Am I done yet? Why? Now, what's the square root of x squared? X plus 1, and then x minus 1. Now I'm done. And I give you that one, very first one, on purpose because it's the easiest one. I know it's blue. It's coming back. That's the easiest one because square root of 1 always is square root. And that even number keeps breaking down. It shows you the pattern easily. Everybody cool? All right, now. Because that has another square root. No, it doesn't. I just showed you that up here, Aiden. Right? You can't make the middle term drop out if it's addition. That's why it's called difference of squares.
So you're just doing it to be as simplified as possible?
Yes. All right. If there was no y squared there, could you do that? X squared has a square root, doesn't it? And 225 has a square root, doesn't it? 15. So we could do it, couldn't we? It would be x plus 15, x minus 15, right? What if there was no x there? What would it be? Y plus 15, y minus 15, correct? Okay. So what must it be if it's x and y? xy plus what, Evan? 15. And then what? X, y. We already did the plus. Minus 15. Done. Does everyone see how easy this is? Will it stay this easy? It will stay this easy. Will it stay this simple? It'll get more complicated, won't it? Look at number 3. Number 3 looks weird, yes? What's weird about it? What's weird about 3? It's a Z, it's not an X, and it's an 8. Is 144 a square root? Or a perfect square? Yeah, so can we do it? What do I do with this even exponent? Break it down. So if I'm square root, what does that mean for my exponents? 2, 1, 4, 2, 6, 3. So what is this going to be? Z 4 plus what? What's the square root of 144? 12. And then what's it going to be? Now, some of you will look at that and see, squared and minus, I got to keep going. Can I? Can I keep going? There's no square root of 12, so I have to stop. Everybody good? All right, now we're going to get to the second hardest kind you can have. This is only the second hardest. Look closely here. Is this a perfect square?
Yeah.
Why? Because 4 has a square root and x6 has a square root, right? Is this a perfect square? Why? 5, 25 is a square root of 5, and y squared is a square root of what? Y. So is this a difference of squares? You said that's a perfect square, difference, and that's a perfect square. So does this work? So all I do is I square root the first one. What is it? 2x cubed. Plus, then I square root the second one. What is it? 5y. And then what do I do? 2x cubed minus 5y. And I stop. Does everyone see how easy this is? It's just square rooting, right? Now, I've left enough space on this page to show you 2 more tricks, or 2 more ways this can screw you up. So everybody's going to write number 5 now. X plus 5 squared minus 4. Why is that yucky? What about that makes it yucky? The x plus 5, correct? We don't like that, do we? What is the trick I've shown you to get rid of something like that you don't like? Replace it with what? Any other variable. What if I make that a? Then what do I have? A squared minus 4. Is that easy? What is it? It's a plus 2 and a minus 2, isn't it? What's a? X plus 5. So isn't this x plus 5 plus 2? And what's this one? X plus 5 minus 2. Hey, I know what 5 and 2 is. I went to kindergarten. What is it? We'll hope the microphone didn't pick that up. What is 5? We'll give you a second chance. What's 5 minus 2? Yeah! X minus 3. Does everybody see how that trick worked? Oh, yeah, positive 3. Is everybody cool with that trick? Okay, that's the second hardest one I can give you. Okay? The hardest kind of difference of squares is this. X plus 3 squared minus x plus 4 squared. Barf! It's ugly, yes? What are we allowed to do to get rid of the stuff that we don't like? Make them letters. A and B. So that's a squared minus b squared, right? So it's a plus b and a minus b, isn't it? What's a? X plus 3. X plus 3. Plus, what's b? Come on.
X plus 4.
Plus x plus 4, correct? What's x plus x? No, that's x times x.
2x.
2x. And what's 3 plus 4? 7. And then this one was a, x plus 3, minus x plus 4. What's x minus x? X minus x is negative x. 0. And what is 3 minus 4? Negative 1. And it's done. Anything new there? Nothing new there. It's just longer, right? It's just doing more of the simple steps you already know how to do. Instead of walking 100 steps, you're walking 200 steps. But it's still just walking. Okay? Don't write this next one down. Just think about this. What would you do with this? Minus 50, wait, x. What would you do with that? Don't write it down, just think about what you would do with it. Look at that and tell me some stuff you could do. You don't even need to write it down. What is some stuff you see there? You see 2 x's, so right away you know, Evan, that you can get rid of an x, can't you? Okay, do you see anything else? I see 50 and 8. Can I do anything with 50 and 8? If I gave you this fraction, what would you do? Reduce it by doing what? Dividing by what? 2. So what would I divide here by? 2. So is this a GCF now? So where does it go? Outside. And in here I have the answers, correct? 4x squared minus 25, right? Now, what do you see there? What do you see? I see 4x squared. Is that a square? I see minus. Is that a difference? I see 25. Is that a square? So what would I do? I do the move. What's the square root of 4x squared? 2x. Plus, what's the square root of 25? 5. Then what would I do? Minus 5. See? Without writing it down even, you're able to do all the work in your heads. Why is it difficult to write it down when you can do it in your heads? Everybody understand? What if I gave you, what if I gave you this? Negative 8x cubed plus 50x. It's a plus. So what do I have to do? If I divide out negative 2x, does it work? Then I get negative 2x, and in there I get 4x squared, 50 positive, 2 negative, negative 25. And now I can factor that. Is everybody good? Okay. Please work on, for the rest of today, which is 26 minutes, page 134. There is all three kinds of factoring on page 134. Okay? Go. Yep.